Hello dear students, in this video I'll continue with the 7th unit of CBSE Class 12 Applied Mathematics, which is Financial Mathematics. Here I will discuss about sinking fund. I'll explain the formula for sinking fund and how we can apply this formula. We'll see from the examples from CBSE Handbook. First we will see what is a sinking fund. A sinking fund, it is a fund which is established by a company or a business entity by setting aside revenue over a period of time, which is required for future capital expense or repayment of long-term debt. Say for example, if a company wants to replace an old machine, say after 5 years, then from now itself it will start saving money and it will deposit certain amount in a sinking fund. So such a fund is called sinking fund. Now this sinking fund, it can be used either to meet a capital expense or for repayment of a long-term debt. So it is a fund that is accumulated for the purpose of paying off a financial obligation at some future designated date. So this is sinking fund. Now before moving to the problems on sinking fund, we will have a recap on future value of ordinary annuity. In annuity, there are two types. One is the payment which is made at the end of each time period, that is ordinary annuity, and another one is the payment is made at the beginning of each period, that is called annuity due. Now first we will see what is this future value of ordinary annuity. Now future value, we know it is calculated as future value is nothing but it is cash flows into 1 plus I the whole raised to n, where CF represents cash flows, I is the rate per period and n is the number of periods. N is the number of periods. Now say for example, if we want to know the future value of rupees 1000 which is deposited at the end of every year, where the interest per period is 5%. Then the future value of rupees 1000 after 5 years, which is deposited at the end of the first year, it is 1000 into 1 plus 0.05 the whole raised to 4, using this formula. Then the value of the future value of rupees 1000 which is deposited at the end of 2 years, the future value after 5 years, it will be 1000 into 1 plus 0.05 the whole cube. Now similarly, the future value of this 1000 rupees deposited at the end of third year is 1000 into 1 plus 0.05 the whole square, and the future value of this 1000 rupees deposited at the end of fourth year is 1000 into 1 plus 0.5 the whole raised to 1, and the value of this 1000 at the end of the fifth year is 1000 itself, because we are depositing 1000 rupees at the end of fifth year, and the value of the 1000 rupees at the same time, it is going to be the same 1000 rupees itself. So here we can see that if we want to know the future value of this ordinary annuity, we can add all these. So here we can see that it is a geometric series where the first term is 1000 and the common ratio is 1 plus 0.05 the whole raised to 1. So using Sn is equal to A into r raised to n minus 1 upon r minus 1. We have here A is equal to 1000 and r is equal to 1 plus 0.05. So the sum is given by 1000 into 1 plus 0.05 the whole raised to 5 minus 1 upon 1 plus 0.05 minus 1. So this plus 1 and this minus 1 will cancel. So if we are able to find the answer for this value, then we will know the amount accumulated at the end of the fifth year. So we will know the amount accumulated. Now in this sinking fund, we know the amount accumulated. We want to know how much sum is required at the end of a particular period of time, but we do not know how much we have to allocate at the end of each time period. Now these values we do not know. So in that case, we can use this future value of ordinary annuity and we can find a relation between the amount accumulated and the amount that has to be deposited so that we can find the size of each payment. So if we consider R to be the amount to be deposited at each time period, so here we have to make a payment of R at the end of each time period up to etc. say n. And now the future value of all these amount to be deposited, it will add up to the accumulated amount A. So we have A is equal to R into 1 plus I, where I is the rate per period, the whole raised to 0, plus R into 1 plus I the whole raised to 1, plus R into 1 plus I the whole square, plus up to etc. plus R into 1 plus I the whole raised to n minus 1. So again we just now saw it was a geometric series. Here the first term is R and the common ratio is 1 plus I. So using the formula Sn is equal to A into R raised to n minus 1 upon R minus 1. Using this, here we have A is the amount to be deposited at the end of each time period and the common ratio is 1 plus I. We have this is equal to R into 1 plus I the whole raised to n minus 1 upon 1 plus I minus 1. So we have A is equal to R into 1 plus I the whole raised to n minus 1 upon I. So the periodic payments of rupees are made at the end of each period required to accumulate a sum of rupees A over n periods with interest charged at the rate I per period. It is given by A is equal to R into 1 plus I the whole raised to n minus 1 upon I. So from this we can find R as A upon 1 plus I the whole raised to n minus 1 upon I. Now this factor, this 1 plus I the whole raised to n minus 1 by I, it is nothing but it is the future value annuity factor. So we can, here we can write this as the future value annuity factor as SNI, that is it is the future value annuity factor for n number of periods and I rate per period. It is 1 plus I the whole raised to n minus 1 upon I. Therefore, we have R is equal to A upon SNI. So this is nothing but this is the future value annuity factor for n number of periods and I rate per period, where R is the size of each installment or payment, I is the rate per period, n is the number of installments and A is the lump sum amount to be accumulated. So this is how we can find R. Sometimes in the textbook the future value annuity factor, the value of this will be given, but in the sample paper the value of 1 plus I the whole raised to n it is usually given. So it is better to use this formula directly. So here it is given a company establishes a sinking fund to provide for the payment of rupees 1 lakh debt. So the amount in the sinking fund should be rupees 1 lakh and it is maturing in 4 years. Here it is given contributions to the fund are made at the end of every year. So here contributions are made at the end of every year. So it is ordinary annuity only. So here n is 4 and it is asked find the amount of each annual deposit if interest is 18% per annum and I is given as 18%. So using all these, we have to find the amount of each annual deposit. So first let us write what is given. So given A is rupees 1 lakh, then I is 18%, which is 0.18, and N is 4. The number of periods is 4. The rate per period is 0.18. We need to find R. Now using the formula, we have A is equal to R into 1 plus I the whole raised to N minus 1 upon I, where writing the entire formula it carries 1 mark, where R is the size of each payment, then N is the number of payments, then I is the rate per period, and A is the accumulated amount. So A is given, implies 1 lakh equal to R into 1 plus I is 0.18 and N is 4, the whole raised to 4 minus 1 upon 0.18. Usually in the question, the value for this 1.18 the whole raised to 4, it will be given in the question. So 1.18 the whole raised to 4, it is equal to 1.9388. So we can use that and find R. So this implies 18,000 is equal to R into 1.18 the whole raised to 4 is 1.9388 minus 1. So this implies R is equal to 18,000 upon 0.9388. So this, when we simplify, we get it as rupees 19,173.4. Therefore, R is equal to rupees 19,173.4. So the amount of each annual deposit is rupees 19,173.4. So writing the formula carries 1 mark, then substituting the values, and if we have to find N or I, if the interest is compounded for some other periods, then we have to accordingly find I, N, all those, and then those steps carries 1.5 marks, and the final answer, the remaining steps, it carries 1.5 marks. So sir, sinking fund question, it was given in the sample paper for 4 marks. Now we saw an example for the sinking fund where the payments are made at the end of each period. Now we will see what will happen if the payments are made at the beginning of each period. If the payments are made at the beginning of each period, it is called annuity due. So we will see how to find future value of annuity due. All these we have already studied in class 11. It is just a recap. So using the formula, future value is equal to cash flow into 1 plus I the whole raised to N. Here the future value of the 1000 rupees which is deposited today, after 5 years it will be 1000 into 1 plus 0.05 the whole raised to 5. Here the rate per period is 5. And the value of 1000 rupees, the future value will be 1000 into 1 plus 0.5 the whole raised to 4. And then it goes on, 1000 into 1 plus 0.05 the whole cube, then 1000 into 1 plus 0.05 the whole square, and the value of 1000 rupees which it will be 1000 into 1 plus 0.05 the whole raised to 1. So here again this is a geometric progression where the first term is 1000 into 1 plus 0.05 and the common ratio R is 1 plus 0.05. So using the formula Sn is equal to A into R raised to N minus 1. upon r minus 1, here we can find the sum of all these. Now in sinking fund, we know the sum of all these, that is, we know the amount that has to be accumulated. We need to find each of these periodic payments. So for that, say for example, if the size of each periodic payment is R, which is made at the beginning of each year, beginning of each time period. So here the amount is deposited at the beginning of each time period, so that a sum of A can be accumulated. And if I is the rate per period, then we have A is equal to R into 1 plus I plus R into 1 plus I the whole square plus up to etc. plus R into 1 plus I the whole raised to n. So here the first term is R into 1 plus I and the common ratio is 1 plus I. So again, using the same formula, Sn is equal to A into R raised to n minus 1 upon R minus 1. Using this formula, we can find the sum of this geometric series as R into 1 plus I. This is the first term. Common ratio is 1 plus I, the whole raised to n minus 1 upon 1 plus I minus 1. So we have A is equal to R into 1 plus I into 1 plus I the whole raised to n minus 1 upon I. So this is how we can find R when the accumulated amount is given using this relation. Now we will see the formula in detail. So the periodic payments of rupees are made at the beginning of each period, required to accumulate a sum of rupees A over n periods with interest charged at rate I per period. It is given by A is equal to R into 1 plus I into 1 plus I the whole raised to n minus 1 upon I. Now this let us simplify further. So it is R into 1 plus I, this 1 plus I into this 1 plus I the whole raised to n. It gives 1 plus I the whole raised to n plus 1. Then here we have 1 plus I into minus 1. So it is minus 1 minus I whole thing divided by I. Or this is equal to R into 1 plus I the whole raised to n plus 1 minus 1 upon I minus 1. Now we just now saw the future value annuity factor. It is given by 1 plus I the whole raised to n minus 1 upon I. The future value annuity factor for n number of periods and interest rate per period is I. It is given by 1 plus I the whole raised to n minus 1 upon I. Now this we can see that this is nothing but it is Sn plus 1 I. Sn plus 1 I, that is future value annuity factor for n plus 1 number of periods and I rate per period. It is 1 plus I the whole raised to n plus 1 minus 1 upon I. So this implies A is equal to R into Sn plus 1 I minus 1. So this is how we can find R if the payments are made at the beginning of each period. Now we'll see an example to understand sinking fund when the payments are made at the beginning of each time period. It is given Mr. X plans to save amount for higher studies of his son required after 10 years. He expects the cost of these studies to be rupees 1 lakh. How much should he save at the beginning of each year to accumulate this amount at the end of 10 years if the interest rate is 12% compounded annually? So here there is one Mr. X. He wants to save amount for his son's higher studies, which is required after 10 years, and he expects that the cost of these studies will be rupees 1 lakh. So an amount of rupees 1 lakh should be accumulated at the end of, it is given 10 years. So we need to know how much he should save at the beginning of each year if the interest rate is 12% compounded annually. So we have let us take, let R be the rupees R be the amount to be deposited at the beginning of each year. So we have A is equal to R into 1 plus I the whole raised to n plus 1 minus 1 upon I minus 1, where A, that is the amount to be accumulated, is rupees 1 lakh, and the rate per period I, it is 12%, which is 0.12, and n is the number of periods, it is 10 years. So n is 10. So using all these we can find R. So this implies 1 lakh is equal to R into 1 plus 0.12 the whole raised to n plus 1 is 10 plus 1 minus 1 upon 0.12 minus 1. So this is equal to R into 1.12 the whole raised to 11 minus 1 upon 0.12 minus 1. Now usually in the question, the value for 1.12 the whole raised to 11, it will be given. So 1.12 the whole raised to 11 is 3.4785. So this is equal to R into 3.4785 minus 1 upon 0.12 minus 1. So it is R into 2.4785 upon 0.12 minus 1. So this 2.4785 upon 0.12, it comes out to be approximately 20.6542 minus 1. So this implies R is equal to 1 lakh upon 20.6452 minus 1 is 19.6542. So 1 lakh upon 19.6542 is rupees 5087.97 approximately. So he has to save an amount of rupees 5087.97 or approximately 5088 at the beginning of each year for 10 years, so that Mr. X will be able to get rupees 1 lakh at the end of 10 years. I hope this video was useful for you. Thank you for watching.